Hey everybody, thanks for checking out my Stable Diffusion 2.0 tutorial where I'm going to give you a brief walkthrough of running Stable Diffusion locally and then training it with some data and making some art with your trained images. So let's jump right into it. Get Python. That's a good first step. So go ahead to the Python website, link in the description, and download Python if you don't already have it. The install is super quick and easy. Next up is Git. This lets you interact with repositories on websites such as GitHub, which is exactly what we need. So go ahead and get Git installed and use all the default install settings as you go through the installer. That is also super quick and easy. So I'm going to assume you had no problems getting Python and Git. If you did have problems, please just comment below and I'll help you out. Next up, I say get GIMP if needed. GIMP is an open source image editor. If you already have Photoshop or something, then that's good. If you only have Paint, then please get GIMP because it's going to really make things easier. And we'll go through a very quick walkthrough on that when we get there. So let's assume that you already have your image editor ready to go. So look at that. We're already 3 of 7 steps done in this tutorial of running Stable Diffusion 2.0 locally. So next up is get Stable Diffusion. In order to get Stable Diffusion locally, all you need to do is clone the Git repository from GitHub that has Stable Diffusion. So with that said, I'm creating a new folder here called Stable Diffusion 2. Open it up, okay? Go to your command prompt, okay? And traverse to this new folder that we've created by typing cd, which means change directory, and then type the folder directory. As you see now, we are entering commands into this folder. That's exactly what we needed to do. First step, just go ahead and type git and make sure that you actually have git installed. As you see, you get all these commands. That means that git is working. If it's working, go ahead and type git clone, and this is where you would then paste the repository link. So I'm closing all these other links real quick. Here is the GitHub repository link. As you see, it has all these stars, it has all these watchers, it has all these forks. It's made by Automatic1111, and that's how you know that this is the official one. Link in the description once again. Once you know that you're on the right link, go ahead and git clone that link right into this folder. And as you see, now this folder contains all of the files of Stable Diffusion. But it's not quite that easy. We also need to get the pixel data model installed. Downloaded and installed. So once again, link in the description to get the Stable Diffusion 2 dependencies, which just contain 2 files. The first file is all the pixel data provided by Stable Diffusion when they trained this model. So here are the dependencies after you download them. They are kind of big, so be warned that it's 4 gigabytes. Here is the pixel data model. So essentially this is what all the digital art that it's been trained on, I mean everything, every image that it's been trained on is all the pixel data is contained in here. Not the images themselves, but the pixel data of all those images is contained in this file. We need to go and drop that into our folder. So go to your Stable Diffusion 2 where you cloned the repository, go to Models, Stable Diffusion, and then you'll even see this text file here. Put Stable Diffusion checkpoints here. So go ahead and paste it. That's what this means, CKPT. That's a checkpoint that contains all the pixel data model to create images, to generate images, okay? The next dependency is this one, GFP GAN. This is a face restorer add-on. It's technically optional, but it's highly recommended because it's a nice tool to have sometimes, okay? It's just kind of what everybody's doing. It's all what all the cool kids are doing. So go ahead and drop it. It goes in a different spot, okay? It goes just in the main directory, as you see. I put it right there, okay? So now we have successfully cloned the repository from GitHub, which contained all the program data and files, and then we went ahead and dropped in the model, which gives us Stable Diffusion's beautiful pixel data, and then we went ahead and dropped in the face restorer add-on. So now we literally already have Stable Diffusion installed locally. The next thing that you're going to want to do is go ahead and launch it, okay? On your first launch, it's going to need to load, okay? And that's what's going to happen right now because this is my first launch with you guys on this tutorial. So while that is loading, that's when you're going to want to go and get your training photos ready, okay? So these are photos of your subject that you need to drop in order to train your Stable Diffusion AI that you have installed locally. So I'm opening up GIMP, okay? And here's the thing. With running Stable Diffusion locally, it's powered by your graphics card. And I have an RTX 3060 Ti, which is a pretty powerful graphics card. And it even still gets challenged by Stable Diffusion, okay? So 512 by 512 pixels is the default size that Stable Diffusion is set to when you open it up, okay, and you start creating art. So when it comes to training the AI, it's also recommended to just go ahead and use that default size. So if you hover over my images, you'll see I've already cropped them all to 512 by 512. Okay, that's what I use GIMP for. If I drop them all into GIMP right here, you're going to see that they all nicely fit into this white square. Okay, it's important to know that if you train your images at 512 by 512, then your Stable Diffusion results are going to look best at 512 by 512. Okay, how could you possibly generate an image of yourself at 1024 pixels if you never trained it at 1024 pixels of yourself? So I hope that makes sense. In terms of quantity, 10 is really not honestly really enough. I would say go for 30 or 50. I think 30 is a nice number. So get 30 images of your subject, crop them all to the same size. And also keep in mind, these are all close-up shots of myself, so I'm not teaching it what my body looks like, okay? So just keep this all in mind. It only knows what you give it, okay? What you're going to want to do is create a new folder called Processed. So as you see here, get your training photos. They are ready, okay? Now we need to do step number 6, train the AI. So we come back here to where Stable Diffusion was launching, and as you see, while I was telling you guys about the images, it finished its initial launch, which is the slowest launch of all, and every launch after this is going to be quick now. So when you run Stable Diffusion locally, you end up getting a link, a local host link. So this is actually a local server that's running on your router right now, and only you are able to access it because it's a local host IP, but you are able to create a public IP as you see here. If you were interested in such a thing, drop a comment below and I'll tell you how to do that. So with that said, now we are in this locally ran, powered, or hosted on our local host router, only accessible by us because it's a private local host IP address. This is a user interface that allows us to interact with Stable Diffusion and start generating art. So as you see, here's the text to image tab. This is where you can go, blah, 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 art. I love art. Hello, YouTube. And then you can go ahead and click generate. It's going to create art that's 512 by 512, and it's going to be at this CFG scale. This slider means like basically what this means is the pixel data coherency. Okay, if it's very low, then it's not gonna be very flexible. Okay, it's gonna be very coherent pixel data, only the most accurate pixel data that it knows about. If you drag it, the higher that you drag it, the more you're allowing it some creative freedom to have more and more pixel data, coherency, differentiation, if that makes sense. So if you go real high, it's going to start putting pixel data together that it doesn't necessarily think goes well together. So I hope that makes sense. The ideal scale is the default one, which is somewhere between 5 and 12. Okay, so I typically find myself using 7, which is the default. Okay. The seed is, as you may know, it's kind of the inspirational number that the pixel data is kind of pulling from, and when it's -1, that means random. So as you see here, if you were to click this dice button, that's what sets it to -1. If you type blah 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 and then you click dice, it goes back to -1. -1 means random, which means every time you click this generate button, it's going to pick a random seed of pixel data kind of inspiration. That's kind of the best way I can explain it. And sometimes there are certain seeds that just give you the exact result that you were looking for. And so sometimes you just have to keep clicking generate, and ultimately what's happening is you're getting a random seed every time, and that's why sometimes the result looks the way you wanted, whereas, with the exact same prompt, whereas it didn't look the way you wanted before. So hope that helps explain seed. But as you see here, I typed blah, 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 art. Hello, I love YouTube, whatever. And we got this pretty cool piece. So, okay, I like that. Okay, let's get into the next thing, which is image to image. So if we come over here to the image to image tab, this is the tab that allows you to load in an image of anybody, such as myself here, and you can basically create a new image inspired by this image. So if I were to type a cool guy with water behind him, then if I click generate, well, with these default settings, it's going to be sampling steps is how many times it's basically cooking this image. Okay, so 20 is a pretty nice number. If you go way up, it's just going to keep cooking it and cooking it and cooking it. And sometimes you might end up with an overcooked image, if that makes sense. The sampling method is just the algorithm that cooks. So I like Euler A, that's the default one. Turns out default settings on this are pretty dang good. The width and the height, once again, 512 is a nice number. As you start getting closer to your final piece, you might try to crank that up and see if you can get good results. This is how you turn on that face restore add-on that we downloaded and talked about earlier. Batch count is, you can probably figure that out. It's going to run the same whole generation again, you know, however many batches that you chose. So if I chose this to 50 and I hit generate, it's going to do it 50 times. So I hope that makes sense. But we're going to keep it on 1, especially when you're testing stuff. I always keep it on 1, and I keep making sure my prompt is good, my stuff is good, my stuff is good. If everything's good, then I might turn the batch up to, you know, 20 and get 20 different results and maybe pick the best one. The CFG scale, we talked about that earlier. That's the flexibility of pixel data and how much uncoherent pixel data it will allow to come into your generated image. So if you go really high, it'll start letting really odd things into your image, like clip art when it's actually a 3D rendering image. You know, like why the heck would clip art be in there? It's because you're turning up the scale. You're allowing it to put things that don't normally belong. And then denoising strength is the most important setting for image to image, which is how far from the original image do you want your new image to be. So the lower this number means it's going to stay really close to your image. If I leave this at 0, it's going to be exactly my image. In fact, it will just load instantly because it's exactly my image. So once again, text to image, that's where you do prompting. You can also do negative prompting, so this will actually remove pixel data from your equation. So if you're trying to get a car but you keep getting a bike, just put bike, and you will definitely remove all bikes from your, you know, and you can also add bicycles, you can also add spokes, whatever you need to add to make sure that you get car, okay? So that's what negative prompting's for. Same deal with image to image, negative prompting. So yeah, now what you really maybe came here for is training the AI. So with training, the first step that you need to do, you can overlook embedding. This is a different feature that I'll cover in a later video. But right now, training is done through what's called a hypernetwork, okay? So we're going to go ahead and create a hypernetwork. So I'm just going to name it Mike Yeah. Shout out to Mike Yeah. And so there we go. We've just created a blank hypernetwork. And all that is just your own model of pixel data, okay? And you're going to take that blank model of pixel data and you're going to start loading it with pixel data by training this AI. So in order to do that, let's start with the first step, which is pre-processing the images. And really what that means is taking our images that we've already cropped earlier, which was actually sort of a manual version of pre-processing. As you see here, we're loading in all these images, and then the pre-processed ones are going to end up in the process folder. Now the thing is, our images are already cropped at 512 by 512, assuming you followed along. And so the image part is not going to do anything. But what is important is this right here, the captioning. So this will actually reverse prompt our images. So it's going to look at our images with AI and it's going to actually create a prompt for them. Okay. And this is crucial for training the AI because every picture needs a prompt with it so that the AI knows what's going on. So I think this is really cool, is that it actually looks at every picture and it actually reverse prompts them. So check this out. This number 1 where it's me in a hoodie with snow in the back, and look at what it picked up. A hoodie smiling for the camera in the snow in the woods with trees in the background. So it actually got that really well. And you know, just to check another one, this one, me and my daughter, okay? And we close that, we read the prompt. A man and a little girl smiling for the camera. It does say while they're brushing their teeth, and you know, in that case we're not brushing our teeth, so I'm actually going to delete that because we're not brushing our teeth. And I don't want to train it on thinking that we're brushing our teeth and that that's what brushing our teeth looks like, because then it might actually, in the future, when I actually want a piece of art of myself brushing my teeth, I don't want it to think that that's what it would look like. I'm going to go ahead and close that. And so yeah, where we've already pre-processed our images now, we got all the prompt files sitting next to it. I do recommend you go through and make sure that all your prompt files look decent. Next up now is the train tab. So choose the hypernetwork that we're training. Okay, we're training our hypernetwork right now with pixel data. Okay, we're making our own model. Okay, forget about embedding settings right now because we're not embedding things. Okay, we're only using hypernetwork stuff right now. So the learning rate is just how fast you're trying to train it. Okay, and kind of think of it like, you know, slow and steady. Okay. So the default number here is pretty darn good, but you can go all the way up to like 5 without worrying about things. You could probably even go up to 1, but when I did zeros, like 3 zeros in a 1, that was too major. Okay, so the default is 4 zeros in a 1, and I can recommend you can push the limits and go up to 4 zeros in a 5. Okay, don't overthink it too much, but this is just how fast you're trying to train this thing. Okay, if you have you know, if you have I guess a slower graphics card, then you can be a little more aggressive with your number, because you know you don't want to wait all day for it to train at a slow rate. Okay, I hope that makes sense. But if you can be slow and steady about it, like do it overnight, you're gonna get better results. Okay, train it nice and slowly. With that said, I'm gonna do it on 3 for this. Okay, so the width and the height of the images that you are loading it with. So we already know this is 512 by 512. Now it's asking for the processed images with the prompts that they're paired with. So I'm giving it that link right here. Dataset directory, boom, processed. Okay. The log is just where there's going to be a text log telling us how everything went. And then the prompt template file, what that means is, let me just briefly explain. As you're training your AI, what it's doing is looking at all your images, and it's reading your prompts, and it's trying to understand what you got going on, and it's adding all this pixel data to a model file called your hypernetwork. Okay, and while you're training it, it has the option to pump out a picture every now and then to show you its progress and go, hey, check out what I'm doing. And the way that works is it uses this prompt template file to pick a random prompt and go ahead and use that as what it displays to you. So if you actually went and traversed to that very template file that it's showing right there, style file words. So we go here, textual inversion templates, and then style file words. You can see what the prompts it has to choose from. So every now and then it's going to pick a random prompt here, and it's going to go ahead and see how it's doing, right? So it's going to say a painting of, okay, and then where it says file words is where it's getting from your processed images. It's going to go ahead and take this. So in other words, every now and then it's going to go like this. Boom. A prompt of a man in a hoodie is smiling for the camera. And it's just pumping out that photo for us every now and then so we can go ahead and see how's it doing on its training process. So with all that said, now that you understand how the template works and how it pumps out a random photo for you every now and then, let me tell you this. There is a specific one for training hypernetworks. This one is cool because it has such a big array of ones. So let's go ahead and change the template to that one instead of this style file words. Let's change it to hypernetwork, okay? Hypernetwork. So now that's the template that it will use as it pumps out photos. Now with that said, it asks you how often would you like it to pump out a photo for us to review. I like to do 50, okay? I want to see it every 50 times, okay? And then with that said, every 50 what, right? It's every 50 iterations of learning your data. With that said, this one right here is asking you how many times do you want it to iterate over your data in order to train this network. I think 100,000 is quite a lot. I'm going to delete a whole 0. So let's go to 10,000. So it's going to iterate over our data and try to train the model 10,000 times, okay? And every 50 steps, it's going to pump out a photo with one of those random prompts, and it's going to end up in our directories over here, and it's gonna give us the ability to check as it goes. So with that said, we got the hypernetwork chosen, we chose the rate at which we're training it, we chose the batch size. We're just running this whole process just one time because it's already going through 10,000 steps. So if we change this to 2, it's gonna go ahead and it's gonna redo this again. So don't worry about batch really. It's just adds, not yet at least. And then once again, embedding here, we're not doing embedding, so you can just ignore that setting at the bottom. And yeah, with that said, these are just 2 extra boxes you can read over, and everything's ready. So you just go ahead and hit train hypernetwork, And what it's doing right now is it's just going to take your process folder. It's going to start loading every image, every prompt, and just constantly running over it, over it 10,000 times. In every 50 steps, it's going to pump out a random photo, like I said, for you to review and see how it's going. From my experience, just let it run for, you know, all of the 10,000 steps if you have to, and see how it went, really. And with that said, I'm going to show you what it looks like now after you have let it run. So in that case, I'm actually just going to hard cancel this because I've already done this before. So don't mind me. You're going to need to let that run for a while. It's not really a quick process, okay? So let it run. With that said, after you let it run, this is what's going to happen. You end up with a new folder here called Textual Inversion. You open it, it'll have the date of when you did it, and then you'll see all your different hypernetwork folders, okay? So in my case, I would just have a Mike Yeah one. So I'm not going to rename it, but this would be called Mike Yeah from earlier in my tutorial when I named my hypernetwork Mike Yeah. So we open it, and you're going to see the images. This is where those steps pop out, okay? So every now and then, it's every 50 steps, for example, it's popping out a random one. And as you see, early on, it's really not good at all, okay? But it does get better, I promise. So not only does it pump out images every 50 steps, but every 50 steps, it also pumps out a backup of your model, okay? So these are all backups. Just in case it started to get overtrained and it starts to give you bad results, you always have a backup here, okay? And these backups are not accessible until you actually put them into the model folder, the same place that we put our Stable Diffusion model earlier, the training model. You don't put them in this one though, you put them in the hypernetworks one, okay? This is where they go. If you want them to be accessible, put them into the hypernetworks models folder, okay? Any one of those backups. So just to go over that one more time, you have your textual inversion folder, the date of when you did the training, and then you have these folders, okay? And for example, this one I trained pretty heavily, and if you look at the images and you keep going on, it really did start to get a lot better. So just for example, a lot of them, see, the thing is the training, the prompts that the trainer uses in that template file that I told you about, like I don't like this one, but I know that it's getting closer because I know my features, okay? So that's the thing. So that's how I kind of know that it's getting somewhere. So with that said, it's just because the prompts in the template are not good, okay? So when you start writing your own prompts, it's all going to be better, okay? This one's pretty darn good, and you know, this one's pretty reasonable. So that's how I know, okay, it's getting trained, okay? So with that said, look at the timestamp on it, 1945-8650, okay? Not to confuse you, but if I were to go back to my hypernetworks here, I can literally find that one, right? That's the idea. And let's say I like the results of that one. I think that one was sufficiently trained. So you copy it, okay? You go back, you drop it into your models, hypernetworks, you know, for example, right there, and boom. Now it is an accessible model, okay? Now it's an accessible model. But now you're wondering, okay, now we need to go create art with it, right? So you launch your Stable Diffusion, just like we always have. This was a different separate install, by the way, separate from my tutorial, just so you know. I hope that makes sense, but alright, so this is opening, and you know, once again, you end up with your localhost link here. So we let that load. There's your localhost link. Now I'm able to access it. Here's Stable Diffusion. Alright, now here's the thing. You can't just type hello, you know, not hello, I don't know why I'm saying hello, digital art of, you know, my hypernetwork. Okay, that's not how it works. Okay, let me show you how it works. What you do is you go to settings here, okay, and you scroll down, okay, until you find the Stable Diffusion section, okay, where we will then find hypernetwork, and this is where you're going to be able to choose the hypernetwork that you've trained, okay, and that you desire to use, okay. So let's say that I choose this one, for example. That's the one I had just pasted in. Now we choose the hypernetwork strength, okay? If we set this to 0, it's all the Stable Diffusion pixel data model, okay? If we set it to 50, then half of it's the Stable Diffusion model and half of it's my training hypernetwork. And then of course you can guess it. If I put it to 1, it's exclusively going to be data from my training. And you have to know, if it's exclusively my data from my training, I didn't train it on nothing else except my face, okay? So it pretty much doesn't know anything else besides my face. So you really need to leave some wiggle room for it to still have Stable Diffusion pixel data in there if you really want good images. So with that said, don't be scared to mess around with this hypernetwork strength and try to find a nice balance between Stable Diffusion's training and your own training to get the best results. Anytime you make changes, like you selected your thing and you do this, make sure you go to the top and hit apply settings and make sure it says that the settings changed. And so now you're ready to go. Now, here's the thing. When we trained the Stable Diffusion model with my data, when you go to processed and read one of these prompts, you can see that my model has been trained to know that when you say a man, that it's me, okay? It may have been better for me to say a Michael Yebba, which is my name, or Mike Yeah, because then I will be training it that I'm not just a man, I'm Michael Yebba, okay? And it's a more specific way. That way I could say Michael Yebba next to a man, and it could be a random man from Stable Diffusion, instead of totally taking exclusive ownership over that word man, which, so just keep that in mind. It really trains exactly how you train it. So train it how you want it to be trained, okay? With that said, you can't just come in here making changes to your prompt files and thinking that it's gonna fix it. It's already trained now, okay? If you already ran the training, then it's already trained that way. So with that said, that's how I did it. So if I type a man, it's going to be me, okay? I can no longer get just a generic man by typing man anymore. I would have to type something else. So as you see, this has features similar to me because it is based on me. So I've basically overtaken the word man. Now, there's going to be obviously lots of hits and misses in this process that you're going to need to work out. You're going to need to probably train things different ways or backtrack and get a different backup file and try that one. With that said, let me just show you an example of switching over to, for example, this one. And I cranked up the strength a lot. So let's see, basically, if this one has better results now that I cranked up the strength. That definitely has my features. But I don't want almost. I'm trying to show you guys a good example of a definite. So just a second. Let's do a man. Okay, that one's getting closer, and I think you're kind of getting the point. Is that it's very much experimental. It's very much, you need to keep training it. You need to keep messing with the settings, and you need to choose your hypernetwork that's trained the best. So with that said, I'm going to click on this one. I know for sure that this one was trained the most. I'm going to hit apply. I'm going to go, as you see, I did lots of different hypernetworks because I was testing this to try to get the best results, and that's exactly what you're going to have to do. And so I can tell already this one has more features of me than the other one. So just a second, because you're getting to see. There we go. Okay, so I can totally rock with that one. So if you end up getting one that you like this one, for example, you can go ahead and use this cool trick, send to image, and it will instantly bring you over to image and load it in there. And then let's say, for example, I turn the denoising strength down a lot so that it stays very similar to this original image, but it will just denoise it 20%. Okay. And I might run this a couple times and try to find a cleaner version of this, if that makes sense. So see how it just it changes by just 20%. Okay. This is like a percentage bar. So what if I wanted to change by 50% instead? So half of this image is going to get changed. Okay. Half of it. And as you see, we got some differences going on there. This is your opportunity to go, okay, let me describe it a little better. A man with a mustache, smiling, with eyes and hair, with wood in the background, right? Now that I'm describing it better, it's going to have an easier time figuring out what the heck's going on. And then I can say smiling teeth so that it kind of fixes my teeth perhaps, or that it will keep my mouth closed depending on what I want to do. So actually maybe I want to say mouth closed, right? To give it an easier time, because look, my mouth closed over here. If I start trying to open my mouth, it's going to have a hard time. So, and then here's a good opportunity to use negative prompting and type teeth so that it stops putting teeth in the picture. So here we go, generating that. And then like my face looks red, so here's a good time to put red, sunburn, like blotchy, for example. And then we can kind of get away from that red blotchy sunburn. And that's actually a pretty good one. So let's take that, right? And then run it again even. And like sometimes it'll ignore your negative prompt. Sometimes it just can't help it and it's going to ignore your negative prompting depending. And so in which case you could turn down the denoising strength, or you could show the teeth, you know what I mean? If sometimes it's like, you know, you're like, I mean, I put the negative prompt there, why is it still going through? It does happen sometimes, okay? And as you see, I just added a period there so that it's like teeth. No, you know what I mean? That's what the negative prompt is for. Needless to say, I'm pretty happy with that image. I know myself very well, and that's a pretty, I could fool my family with that picture. They would think it's real. So if you like an image, okay, if you've landed on one that you like, okay, there's a couple different tricks you can do. You can crank up the resolution to 1024 and try to run that and see how it comes out at a bigger scale. Or you can use like a free image upscaler, such as upscale.media. And all you do in this case is you would take a 512 by 512 image like this, and you just would drop it in, and it would very quickly upload it, as you see. And then well, as you see, you can even go all the way up to 4x, but you can use this as a little tool to see how well it's doing. And it definitely adds a lot of clarity on certain features, especially at the 4x. There's no doubt about it. I mean, you can see right there, the glare even on the teeth and the lip is a lot more visible. This is a great tool because you're getting the detail out of the 512, but then you're upscaling it without destroying the image. So we can do like realistic digital art, and then negative prompt photograph, portrait, and then now let's say we're going for more of an art style rather than a real photograph. So, and look at that, see, so now we're definitely getting, but here's the problem. My AI, my model file was not trained on this type of art style, okay? So in which case I'm going to scroll down and I'm going to turn my strength down to allow Stable Diffusion's model to take more of a role in this case. So now if I turn it way down, I'm losing all of my training, but if I turn it up here, I'm gaining it back. So I put it at like 0.8, make sure you hit apply. Now I'm allowing more of Stable Diffusion to come through. And that's going to help the quality of the image, because right now it looks destroyed. Okay, and see, like that's kind of cool. Kind of resembles my look, but it's stuff that was from Stable Diffusion. This model, you know, not mine. And so yeah, you just kind of run that a few times. Like, and then for example, okay, this one doesn't quite look too much like me yet, but I can bring it over to image to image. Here's the cool thing. Bring it over to image, come back to settings, crank up the strength again, hit apply, and start image to imaging this, and it will start to look more and more like me. You can even roll it a couple times to and then like do it step by step, like okay, that's incrementally more like me, and then you know mess around with the denoising strength, so it will make it 30% different than this one. So you know, you get the point. It's kind of trial and error. So like, let's just say that one, for example, and then run it again. If you know, each time that it gets closer and better, you know, modify some settings, send it over to the image to image again, and keep trying to do that. So now we're getting pretty lipsticky here, but you get the point anyway. Curious to see if I can't get this to image closer to me. Anyway. Well, I really appreciate y'all watching, and I hope that I could have given some useful information, and sometimes you end up getting some artist watermark. You can't help but wonder. Anyway, thank you so much for watching this, and just comment below if you have any questions, and I will be here to answer them. Have a good one.